All right, so next up we got radical equations here. So for these ones, we want to isolate the radical first and then square both sides to get rid of the square root and solve the resulting equation. And then lastly on these ones, it's actually a lot more important than the fractional equations. We got to check for those extraneous solutions. And for that, we need to plug into the original equation and make sure it works out here, okay? Okay, so number 6 here, when we already have like a radical equals a radical, I can actually just go ahead and square both sides because both of those radicals are kind of isolated. And so when we square a radical, it just goes away. Okay, and so then we can just solve this like a regular equation here, linear equation. Since it's all first power, we can just get all of our variables on one side. So I'm going to subtract x over here, and then I'm going to get all my numbers to the other side. So I'm going to subtract 10 over there. So this will give me negative 2x on the left side equals negative 14 on the right side. I would divide by negative 2, and then x equals 7. Now before I box that up, I should go back in and plug that 7 into the original equation. So I would say the square root of 10 minus 7 equals the square root of 7 minus 4, which really just says square root of 3 equals square root of 3, which is of course true. I'll put a little check mark there. And so that means that x equals 7 is a legitimate answer. Okay, so let's go to number 7 now. So I'm going to subtract 8 from both sides. We want to isolate the radical here. So that's going to be the square root of 44 minus 4x equals x minus 8. Now I need to square both sides. Now when I square this side, the radical just goes away, so that's nice and easy. However, when I square this side, it really means like multiply it by itself. So we would do x minus 8 times x minus 8, and we do need to FOIL that. So we got first times first is x squared. Outer times outer is negative 8x. Inner times inner is also negative 8x, so I get negative 16x. And then last times last is plus 64. So I can write that out there, okay? So I see here we do have a quadratic, so we need to get one side to 0 and try factoring. So I'm going to move this stuff because I want my squared variable to be positive. So I'm going to add 4x right there and subtract 44 right there. So we get 0 equals x squared minus 12x plus 20. Now I can go ahead and try to factor this. So we would be thinking of two numbers that multiply to 20, add to negative 12. And so that would be, what would that be? Add to negative 12, oh, 10 and 2. Negative 10, negative 2. I can use the shortcut here since it's just x, so x minus 10 and x minus 2. And so then I would set those equal to 0. So if x minus 10 equals 0, that means x equals 10 if I add the 10 over. And then if x minus 2 equals 0, that means x equals 2. Now again, I do need to double check these into the original equation to make sure they still work. So I'm going to go ahead and do that. So I'll do 10 first. So I'm going to say 8 plus, and I'm going back to that original equation before I move the 8. And we get 44 minus 4 times 10. And that's supposed to equal x, so I'm going to put equals 10 since I'm plugging in 10 right now. I'm going to do this all over again with the 2. So this says 8 plus the square root of 44 minus 10. Oh, wait, no, 44 minus 40, that is. 4 times 10 is 40, so 44 minus 40 is just 4. And so that's supposed to equal 10. And so this just says 8 plus 2 equals 10. Obviously, that's true. And so x equals 10 is a legitimate answer. All right, and so now I'll do that again with 2. Okay, so I'm going to say, what is it? 8 plus the square root of 44 minus 4 times 2 is supposed to equal 2. So that means 8 plus the square root of, let's see, 44 minus 8 is 36. So that's saying 8 plus 6 equals 2. So that's obviously not true. And so that means 2 is an extraneous solution, and I should cross it off. So the only answer here is 10. Now, remember when we get an extraneous solution, that does not mean that we did anything wrong. Extraneous solutions, by definition, they're solutions that come up by doing the math correctly, but they are incorrect. The big reason I always say why we get the extraneous solutions kind of goes back to, if we look here, we know that like when we create a square root, like we're supposed to put a plus or minus in front of it, but when the square root's already in the problem, we don't put the plus or minus in front of it. And so you can kind of see as we plugged in here, if this would have been a plus or minus in front of the square root, this actually does work as the minus version of it, but we don't put the square root there in this case. That's why it did come out extraneous. All right, let's go ahead and take a look at number 8 and 9 now. All right, so for number 8, kind of a couple different ways we could look at this. I'm going to go ahead and erase this all over here so I can have a little bit more space. I kind of always like to look at this in 2 different ways on number 8. They're kind of different, but in a way they're kind of the same. It kind of happens a lot in math where it's like 2 techniques look different, but when you really know what you're doing, they end up kind of being the same here. So the first way I'm going to do it, you can rewrite this as like the cube root of x squared, right? Because that fractional exponent, the denominator is the root and the numerator is the exponent. All right, so that's going to equal 9. All right, and then to get rid of the squared, we would square root both sides. And so I would say the cube root of x equals, and then since I created that square root, I would do a plus or minus 3. All right, and then I would do a third power here and a third power there. Shoot, I should have done that in a different color. Hold on, let me show that in a different color since it is kind of a new step here. Let's do that in, let's go pink. All right, so third power here, third power there. So then I get x equals, all right, and if we think about it, positive 3 to the third power is 27, 3 times 3 times 3. Negative 3 to the third power is actually negative 27. Negative 3 times negative 3 would be a negative, so I do get 2 answers there, okay? I could have also written it as x equals plus or minus 27. That would have worked as well. Now the other way I kind of look at this problem is that if you think about it, hold on, I'll kind of do this in, what color have I not used? Blue. Okay, so if you look at it like this, the other way I kind of think about this problem, if we have x to the 2/3 power equals 9, the other technique I've used is you can kind of raise this to the power that's just going to make it x to the first, and that's always going to be the reciprocal power because one base with 2 exponents like this, oops, that's not what I meant to do. One base with 2 exponents like this, like we multiply the exponents, so that would be cross cancel the 3's, cross cancel the 2's, that would be x to the first power. So then I would have to do the same thing here. And so then if I interpreted that as the square root of 9 to the third power, and I remembered that I created that square root, so I have to put a plus or minus in front of it, you can see how that would lead us. That's really kind of the same thing we did over here, and that would lead us to that plus or minus 27 answer. So it's kind of another way to look at those fractional exponents, if that makes sense to you. Raise it to the reciprocal power. Okay, so now for number 9, let's go ahead and do that. So for this one, I would write it as the square root of x to the third power equals 8. Okay, and so my next step would be to take a cube root on each side to get rid of the third power. Now for this, it's going to be square root of x equals, and then the cube root of 8 is just 2. Now very important on this one, it's not plus or minus 2, and so we should really make a note over here. The plus or minus is when you create an even root. So an even root, for example, a square root is the most popular, but it could also be a fourth root, etc. So it doesn't apply here to the third root, okay? The reason why, if you think about it, like x to the third equals 8, like x can only equal 2. Negative 2 does not make that true because negative 2 to the third power does not give you 8. Negative 2 to the third power gives you negative 8. However, if we have x squared equals 4, like x could equal 2, but x could just as easily equal -2, because -2 squared does give you 4. And so that's why that plus or minus comes up when we do the even roots and not the odd roots, because the odd powers kind of keep their positivity or negativity, whereas the even powers turn everything positive. Okay, so then last step here, I'm going to square both sides. Again, I'm not going to do a plus or minus here because we don't do a plus or minus when we create a squared. We really do it when we create a squared root. So I would just say x equals 4 here. Okay, last set here for absolute values. We want to isolate the absolute value first, split it into two equations, turning the outside of the equation negative in one of them, and then solve each equation separately. And then we only need to check extraneous solutions on these ones if the absolute value equals a variable or a negative. Okay, so for this one, I'm going to subtract 1 on each side. So I get -4 times the absolute value of -x plus 5 equals -4. Now, this -4 out front, we are not allowed to distribute that into the absolute value. I know absolute values are kind of like parentheses, but not fully, and so we cannot distribute into them. So instead, what we want to do is divide by -4. So we get absolute value of -x plus 5 equals 1. Okay, and then we're ready to split this up. Okay, so we're going to split it into two equations. The first one, I'm just going to write it without the absolute value. -x plus 5 equals 1. The second one, I'll do -x plus 5 again, but this time it's going to equal -1. Okay, so now we need to solve these. So I'm going to subtract the 5 over here. So -x equals -4, which means x equals 4. Over here, I'm going to subtract the 5, and that means that -x equals -6, so x equals 6. Okay. Remember, since my absolute value back when I split it up did equal the positive number, I kind of don't have to check for extraneous solutions. These are just my two answers here. Okay, next up we have our absolute value equal to x, and so this one I probably will, or I know I will have to check for extraneous solutions. But first I'll go ahead and solve it. So we'll say -2x plus 15 equals x, and then we'll also say -2x plus 15 equals -x. All right, so I got variables on each side, so I'm going to add or subtract all the variables to the same side. So on these ones, I would add the 2x over to the right. It'll just be less steps that way. And then I'll divide by 3, so over here x equals 5. All right, and then on this one, I will add the 2x over here again. And then this one would say 15 equals x, so that one's actually already solved as well. Now I do need to check these for extraneous, so I should plug it into the original absolute value equation. So this one says the absolute value of -2 times 5 plus 15 equals x again, so that's 5 in this case. So this one says absolute value -10 plus 15 is 5. Absolute value of 5 equals 5. That is true, so 5 is one of my solutions. All right, and then the other one says absolute value of -2 times 15 plus 5. Wait, -2 times 15 plus 15, excuse me, equals 15. Plug in x again there. So absolute value of -30 plus 15 equals 15. Absolute value of -15 equals 15, which is definitely true. So in this case, my two answers are both correct. Okay, lastly, we got number 12, and we don't have a lot of space for that, but good news is we don't need a lot of space because on number 12, I actually already know the answer is no solution. Okay, and the reason I know that is if we look back, we have an absolute value equal to a negative number. There's no x value in the world that can turn an absolute value into a negative number, right? The absolute value turns all the numbers into a positive. So anytime that your absolute value is equal to a negative, you can actually just stop and say no solution. Now we need to be careful because if you look at number 10, Number 10, like some people might have put no solution here because the absolute value equals a negative, but you can see like we have to isolate the absolute value first, right? And so by the time we isolate the absolute value, it's actually equal to a positive, so that does work. So it's not necessarily the beginning of the problem. It's more like at the point that the absolute value is isolated, it needs to be equal to a positive or it's not going to work.